Hello, everyone. Hello.
Hello, Mr. Ture.
Yeah, are you hearing me?
Yes, I am.
All right. Okay, let's wait for 5 minutes and then we can start the class.
Okay. Yes, sir. Yeah, maybe they will lock in soon.
Yeah, sure.
So, all right. All right. And then we can wait for 5 minutes there.
Sure, no problem. So how are you finding the material?
Yeah, it's okay. We're going through it.
Okay.
We as for us, we have few working in the same institution.
Okay.
So what we decide is to have maybe today after the lesson, then tomorrow we will sit together, go to the office and do some practice.
Yeah, that's good. Go through those things. Once that material is clear to you, I'm sure you will be okay with what comes, anything that comes from that end.
Okay.
Yeah. So
yeah, we'll do that. But in case, yeah, I say about in case if you have questions while we are doing the revision, can we contact you?
Yeah, sure. Why not? Through WhatsApp.
Okay. All right.
Yeah.
I will do that.
That's okay. Are you hearing me?
Yeah, loud and clear.
Is it very clear?
Yes, loud and clear.
All right. So I log in earlier so to see whether things are clear.
Mm-hmm. Yeah, it's clear. I'm hearing you very clear.
That's good.
All right.
Good afternoon, Mr.
Afternoon, how are you?
I'm fine. It's Bintu.
Bintu, okay. Bintu, welcome on board.
Thank you.
Okay, I hope the line is clear.
It's so clear. It's just that I'm on the way trying to go home. So, but I'm connected.
Okay, but you are hearing me clearly, right?
Yes, I'm hearing you.
All right. So in next 3 minutes, I'm going to start the lectures. I log in earlier to see whether there will be any technical difficulties. But so far, I think everyone is hearing me very clear. If we are not, please maybe send a chat to know.
Hello?
Yes? Hello?
Yes.
Okay. I hope everyone is getting me. very clearly?
Yes, yes, we are getting you. Sure.
All right, that's good. And so I think, where did we stop last class? I think we were solving some real life application, like, you know, calculating the targeted profit.
Exactly. 3.1.4 example.
Okay, that's good. So today also, I think we will look at one application of linear equation where we will solve one. Then from there, we will look at quadratic equation in details. Some of this, or in fact, most of them, you know, I think all of us have seen it in high school, but some of us have finished high school a long time ago. So I think this is very important to do this refresher, to go through these materials. Normally we should have started with the derivatives, like differentials and others, but it's not a bad thing to refresh our mind. We have done it in high school. So today we will look at also one application. We will look at linear equation application of it. Here we will have a macroeconomic model or income determination. So we will look at linear equation, but a real life application. We will look at that. That's the first thing that we will check. So, and this real life application has to do with macroeconomics. I don't know whether you people you have taken macroeconomics, but just principles should be fine. So we look at macroeconomic application of linear equation. We look at this. Today, this is what we will cover. Then the second part, we will look in detail quadratic equation. How do we solve it? What are some of the methods that are available to solve it? Quadratic equation. You look at it. You look at quadratic equation. If time permit us, we will also look at system of equation or simultaneous equation. People call it simultaneous equation. Simultaneous equation. So we are just following this material I shared with you people. Is what I'm following. So some people call it system of equations, but this simultaneous is what linear. It's linear simultaneous equation. So it's just some people will call it systems of equations. For writing this with a mouse is very difficult. So this is what we will look at today. If time permit us, I don't know, we have 2 hours, 5:30 to 7:30. So this is what we will look at. We will start with a real life application of a linear equation, the macroeconomic model. We will look at this, how we can use linear equation and solve macroeconomics problems. So if you go to the material, let's see. Okay. So let's go on and start and look at the first one. This one. Let's take this example. You can find this in the materials I share with you. I can't remember the exercise. You understand? So we have a situation like we are given a macroeconomics model. This is a macroeconomic model. So if you go to the material I give you, you find this example there. So first, this was given to us, the first equation, and it says y equals to c plus I with this mark. And also the second equation given to us is they say c equals to a plus b y. We have this. So we have this. So this is a macroeconomic model. We have one equation and another equation. So if we go back to this, let me share the question with you people. Let's go back. Okay. This is the question. So we have this question. It says consider the basic macroeconomic model. So we have the first equation as y equals to c plus I. If you look at the I, on top of it, there is a dash there. So the dash there is telling you is a constant. So the second equation says c equals to a plus by. So if you look at this macroeconomic model, the y there, this y is the GDP of the country. So it's important first, before we solve this, we know the names of the parameters. So the C there is what is the consumption. Is the consumption. It's the amount of goods and services consumed by the household or the consumers. This is the consumption. So here, this does, it means that this variable is constant. And it's saying that investment is constant. So the idea is what is the investment? In short. So C, we know it is the consumption. And the A here is nothing but a constant. So the B here is the marginal, we call it MPC. What does MPC mean? It's the marginal propensity to consume. So if, for example, when we say that the B is equals to 0.8, what we are saying here is this: out of every dollars that a consumer has, 80 butul is spent on consuming, while 20 butul is spent on saving. So the B there, the B parameter, is called marginal propensity to consume. So what it stands for is that, let's assume that B is 0.8. So what it means is that when a consumer, each dollar a consumer has or earns, he or she spend 80 butus on consumption and spend the 20 butus on savings. That's the meaning of marginal propensity to save. I hope that is clear. Can we mute our speaker, please? So we are disturbing the class. Okay, so we have this. So we define our variable. Here, this GDP, the Y is a variable. The consumption also is a variable. But this investment, because we have this dot here, is telling us it's a constant. And A is a constant. B, which is the marginal propensity to consume, is what? Is also a coefficient. So when you have this kind of equations, we have macroeconomic model. So the question here, what we want to solve, we want to know the value of the variable. We want to solve this equation. If you can remember, we talked about what we mean by solving an equation. And when we talk about solving an equation, it means we want to find the numerical value of the variables. And the variables here are what? Y and C. So we want to solve this equation. What we mean is we want to find the numerical value of this one and this one. So how do we go about when we have a system? If you look at this also, you should know it, you should identify whether it's a linear, you should be able to classify them, whether they are linear or quadratic. So the variables that we have here are Y and C. Because investment here with this dash is telling you is constant. So when we come to the second equation, consumption, this one is a variable, this one is a coefficient, this one is a constant, the A, B is a coefficient, so this Y is also a variable. So if you look at it, the Y and C, they are the variable, Y and C. And the highest power they have is 1. In here, Y, the power here is 1. 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 So we can say that the equation 1, which is this, is a linear equation. Equation 2 also, we can identify it as a linear equation. But the task here is we want to solve this linear equation, 2 equations given to us. One can even call this as a system of linear equations. So how do we solve this kind of model? We have 2 equations. The first thing that we should do, we can substitute. So it is important we understand. Let's go back to the.
You were about to call me.
Let's go back to something like that. So we have this equation. So what we do is very, very straightforward. So let's go to the next slide and try to solve this equation. So let's rewrite it again. So we have the equation Y equals to, so after defining, we have defined our model, we understand, we know that B is the marginal propensity to consume. What it measures how much you will spend on consumption for each dollars that you earn as a consumer. So Y here, if you looked at it, is the amount of consumption. I don't want to go into details for now, but the A here is the amount of consumption that you will do when you don't have any income. But we will look at this in details in our next lectures coming. So let's here now, the task is just to solve the model. How do we solve the model? Remember, this chapter is all about solving equations. How do we solve this? And to solve this, we want to find the numerical value of Y and C, or find them in terms of parameters. So the first task here, we have C plus, I'm stating the models or the equation. And then the second equation is C equals to A plus B. Please, let's mute our, next time I will put everyone on mute. So we have these 2 equations. We have these 2 equations. So what is our task, our goal here? First, what we want to do, we want to solve the model, solve in terms of Y and and C. This Y and C are the variable. The second task that we want to achieve here, let's assume if we assume that the investment equals to 100 and A as in the equals to 500 and B, that is the MPC, marginal propensity to consume, is 0.8. So we want to find Y and C. So this is our task that we will be doing here today. First is what we want to solve Y and C in terms of the model. If we solve them, then we can use these numbers. We can use these numbers and substitute in the equation. This is 500, by the way. But before we do this second task, we have to solve this. So how do we do this? The first thing that we should do is substitute this C into here. So you will see, to do that, you will have Y equals to C. And what is C? C is A plus BY. Then plus investment. This investment here. So what we do is substitute this, then we have this equation. Remember now, we have this one equation now. We can call this equation 1. We call this equation 2. And the new equation on the reduced equation, we call it equation 3. So if you look at equation 3, the variables that we are having now is only one variable. The rest are either constant or coefficient. This is a variable, which is Y. This is a variable. So if you look at this equation 3, Y here, the power is 1. We talked about this in our last class. You can check our last video. The power here is 1. Hence, since the highest power in this equation is 1, then we classify it as linear equation. So how do we solve this linear equation? The next step, what you have to do is to collect the like terms on the one side of the equation. So this one and these ones are like terms. So we have Y. This will come here to the left-hand side of the equation. Obviously, this plus sign will change to negative. We have BY equals to A plus investment. So obviously, we can factorize this. So when we factorize the left-hand side of the equation, we will have what? Y into 1 minus B. Because if you expand this, you will have this. So Y is here, Y is here. So that's why we have a common factor outside the bracket. So equals to A plus the investment, which is constant. So the goal here, remember, we are trying to solve the equation. The goal here is to find the value of Y and C. So here, Y, we will have to make it to stand alone. In mathematics, we make it the subject of the formula. So how do we do that? Equivalently, we can write this. Let's come here. So we can set Y into 1 minus B equals to A plus investment. We are interested in Y, so we divide both sides by 1 minus B, 1 minus B. Obviously, we cancel this and this. Then we will have Y equals to A plus investment all over 1 minus B. So this is the solution for Y. So we have solved for this already. But we can go on and express Y equals to A plus investment in many ways. So going to the next slide, we can express this in many, many ways. For example, let's look at from this. This is what we had. A plus investment all over 1 minus B. Equivalently, we can express it as this as well. Y equals to 1 over minus B in bracket A plus investment. So in economics, this has a very, very important interpretation. We call it expenditures multiplier. Please note this very well. Let's pay attention here. We call this expenditure multiplier. We call it expenditure multiplier. But we can also go on and express this in different ways. We can, like this, we can multiply this by this. So we'll have something like A over 1 minus B plus 1 over 1 minus B times investment. So if we express it like this, then we can call it expenditure multiplier. Like this, because it's capturing the impact of expenditure on output. But if we go on and express it like this alone, we will call it, as in your textbook, investment multiplier, because it's close to investment here. But here we are taking the totality of these two. So it will become expenditure multiplier. But when we separate them, then this becomes expenditure multiplier, investment multiplier. So, however, if the combination of this and this, still it will give us what? Expenditure multiplier. So the one that is attached, the parameters or the coefficient attached to investment, we call it expenditure multiplier. But when we have this one and this one, when we add them, that's the time we call it expenditure multiplier. So these names, they have economic significance. Remember, our course is about application of mathematics in economics and other social sciences or business. So then we'll have expenditure multiplier. So whether you express it like this is correct. Whether you express it like this is correct. Or this one, they are all correct. The reason why I'm expressing in different ways is to understand certain components. So, because when it is like this, you cannot see the expenditure multiplier, which is the one. So this 1 over 1 minus B is the expenditure multiplier. But when we expand this equation, this one, to here, then this coefficient will have two terms. The first term is the first term, we have it here. The second term that is attached to the investment, we call it investment multiplier. But when you add this one and this one, that's the time you have the total expenditure multiplier. So you can express it in many ways, whether this or this or this, they are all the same. The only difference is that you can have some economic significance when you expand them or factorize them. From here, we expand it, we have this and this, different components or different terms. The first term we have this, the second term we have this, the second term here is the investment multiplier. I think in the material I gave to you is expressed as this. So now that we know the value of, Y as, but normally I would prefer to express it like this, 1 over 1 minus B. This is my preferred way of expressing the solution. Then I have my this, close this. So we will be running out of time, but I will log in again. So you can also log in as well in case it just cut off. So this is my preferred way of expressing the solution. So now we have solved for the y. If you look at here, we don't have any variables here. There is no variable here. We don't have any variable here. They are either coefficient or constant. So that's the time you find. If you looked at here, we just remove the c. So we have the value of y. C is removed completely from there. So the solution, solving for y, means that we want to remove C from it. And we did that exactly. So there is no C in this solution. So after finding y, then we should go on and find C as well. If you remember, we said that C is what? C equals to A plus by. But if you remember, we have already found what is y already. We said y equals to what? 1 over 1 minus b in bracket multiply A plus the investment. We have that. So what we will do now to find C, then we will substitute. We will substitute this. This is what I was afraid of. That's why I mute all of you last class, the noise. So we substitute this into this. So we will have C equals to A plus B. So we remove this y and substitute it with this value. So we will have something like this, 1 over 1 minus b multiplied by A plus investment, which is constant. So we have this. So to solve this, we can expand the bracket or the parenthesis. We can expand it. So to expand this, we will have, if we expand it, we'll see equals to A plus, let's have this. We will have this times this, it will be over 1 minus b. We have this. Then into A plus the investment. We have this. It's just we multiply this b by this one, we have this. So next what we will do, we can expand, we can multiply this by this. So we will have something like C equals to, we bring our A down, plus this times this, it will be BA. We have BA. Yeah. So we'll have BA plus BI all over 1 minus B. We have this. But we can go on and simplify this further. Remember, this is over 1. Mathematically, it's okay. So we have this. We can stop at this place. But in mathematics, it's always important to simplify, because when you simplify, you can see pattern in the mathematical expression. So what we will do here, we will look at the lowest common denominator between this term and this term. Obviously, it will be what? 1 and 1 minus b. So what we will do is simple, equivalently, we can go in here. So C will be what? Equals to, we take this denominator, which is 1, which is 1 minus b. So this one into 1 minus b, it will be 1 minus b. So this A times 1 minus b. So obviously 1 minus b into here, it will be 1. Then we'll have plus 1 into BA plus B investment as constant. So obviously we can go further. This C here, it will be equals to this multiplied by this. We will have A, this multiplied by this minus AB, then plus BA, and plus B investment, all over 1 minus B. But if you looked at this, there is we can cancel two terms here. This term and this term, they are the same. Even though this one starts with A, this one starts with B, they are the same. So we can cancel these two. So when we cancel these two, then we'll have our C as what? C equals to A
plus BI.
A plus B investment, that's BI, all over 1 minus B. So this is what we will have as B. Now we have solved the first text already. We know our C now. So we know our Y now, and we know our C. So what we will do in the second part of the equation, second part of the question, we have done this already. We know our Y, we know our C. Now is to just use these numbers and substitute them. Then we will know our value of Y and C. So let's go on and do that. So now that we know what is Y, which is 1 over 1 minus B, and we know what is our C, which is A plus BI, that is our investment. In this model is constant, all over 1 minus B. So now we have this. And if you look at these two equations, if you look at Y and this, you will see that there is no variable here. So when you have these two macroeconomic model, the goal is to make sure that you solve for the C, you solve for the variable rather. And when you solve for the variable, then here, anything that is there should be either a coefficient or a parameter or constant. So that's what we mean by solving this macroeconomic model. But the question went further and said too, if we know investment, which is 500, I think it was 100 rather. And it says if A is 500, and if B, and remember this B is very important, we should be able to know it. So what, if they said B is 0.8, what it means that if you have $1 as a consumer, you will spend 0.80 bututs on what? On consumption. So you will spend the other 20 bututs on what? Savings. So the money that you have as a consumer, you will either save it or consume it. So this parameter here, B parameter, in economics, we call it marginal propensity to consume. So remember, this marginal propensity to consume, if we have marginal propensity to consume, obviously we will also have marginal propensity to save. So if you add this and this, they should give you 1. So if you have $1, it is telling you 80 bututs you will use it to buy goods and services. The other 20 bututs you will use it for to save in a bank or somewhere, or susu, whatever depends how you save. So this is the economic interpretation of this B. It's marginal propensity to consume. If it's 0.8, it's telling you 80 butut of each dollar that you got as a consumer. It tells you each $1 you have as a consumer, 80 bututs is used in consumption, while the other 20 bututs remaining, you use it to save. That's the economic interpretation. Remember, this course is all about how we use maths to solve business and economics problems. So now let's go on and try to solve this. But they say that if